Thank you, Daniela, and welcome everyone to another One Spatial monthly webinar. For those who have not seen me present before, my name is Michael and I have been with One Spatial for about 5 years, and that's pretty much been my entire spatial industry experience, really. I've discovered FME here and started using it not long after, and over time have progressed from sales into doing a bit more technical work and pre-sale stuff. Today, we will be revisiting GDA 2020 due to some new legislative changes in WA in relation to mining, but as well provide an opportunity to those who still might need to migrate some stuff over from a few years ago or some struggling data sets that still need to be addressed. Quickly, just taking you through the agenda, loosely how it's going to go. I'll provide some recap and context on why and what GDA is. From more of a mining perspective, what processes are affected and how it relates to your day-to-day to what you have to submit to the government. The actual process of migrating to GDA 2020 and some other things associated as well. And then just some final comments and things, some closing remarks before I wrap this up. So first off, I'll just go through some of the recap and some of the context behind this. We'll just go back to the start where GDA 2020 was initially rolled out and adopted by authoritative bodies. So you can see at the start, Geoscience Australia rolled it out in 2017, but the actual datum is something created by the ICSM in Australia. And then it started being adopted and implemented by the states and territories from about 2018 through to about 2021, 2020 or so. And throughout this time, a lot of the data has just been made available. I'm sure if people have gone to the government to get data from their website, you'll notice that it's available in both 94 and 2020 during the transition. A good thing to note is Landgate WA, they're one of the first to make it mandatory for 2020 submissions, which is kind of interesting. And it's just an example of some of the data that is involved with this GDA conversion in relation to the timeline. So you've got a lot of utility network data, cadasters, so land parcels, roads and highways, lots of different environmental data as well. And you'll see some of that in the presentation today as well. So going through the recap, if you've watched our webinars or if you've been watching for quite a while, you'll know we've done this back in 2020. That was actually my first webinar I ever did, just to going through aligning a workflow and as a bit of an overview. But then a year later, when we had some use cases and some stories out there, we ran it back with Jamie from Bayside City Council in Victoria and Richard as well to go through how they did it and a bit of an open discussion on the move. And yeah, now that brings us to today. So I'll provide a bit more detail about what's happened now that we've decided to revisit this. So this year there was a amendment introduced by the Department of Mines, Petroleum and Exploration that essentially made all data submissions that are under the impacted legislation to now be in GDA 2020. So this is just a screenshot of what it looks like on the right, and you can see down the bottom the listed legislation that this impacts. So just running through a bit of a summary, it's essentially it's just an amendment, it's not new legislation, so it just changes the previous datums from 94 to 2020 that are referenced. It comes into effect next month, so this is pretty quick, hence why we want to go back and cover this to anyone that might want it. And yeah, while this is a mining focus, of course, we'll be going through things like communal practices, preparations, FME transformers that's involved in datum conversion. That's going to be helpful for everyone. Okay, so GDA 2020, just really quickly, stands for Geocentric Datum of Australia 2020. It's the newest one that's moved on from GDA 94. So it's about 30 years from then and addresses the 2 meter shift or so that we've drifted northeast due to tectonic movement. So while for some disciplines, this isn't going to be really affect you at all, there's other disciplines, that are much more large scale, things like say underground asset location where being 2 meters out is really really important, particularly data that's been GPS collected rather than, for example, if we look on the right, if that's GPS collected, you might end up something like this. If it was collected via say rules, where it's underneath the footpath, that might not happen, but it just depends on how the data is collected. But yeah, you can see if that's the case, then this is something that definitely needs to be addressed. So I'll just run through now how the impacts for this happen in mining, and some of the required data and reports that are affected. First of all, just wanted to go over, I referenced a few portals that they have to submit a lot of reports through, and this is just an example of what the interface looks like. So this has been quite mandated and streamlined within the industry to make sure that this is a process that's carried out, and compliance and transparency is the priority. So quickly, mineral exploration reports, they're there for documenting essentially the geological and exploration activities from mining projects. So they include annual reports, partial surrender reports, full surrender reports. Surrender reports, by the way, is just when a mining project's come to an end. Essentially, they need a full record of all the activities that's been conducted during its life. And it will contain things like geological programs, drilling, collection of soil, rock, groundwater, mineral samples, things like that. The reports then have to be submitted in prescribed formats, and shapefile is one of them. So this relates quite heavily to that, or essentially being in the right datum conversion. These are the things you need to be making sure of. And as I said, this is going to be a note that I have throughout these report slides, is just having it this way just means that compliance and transparency is just much easier to keep on top of for the government. Form 5 operation reports. So it's an annual report, and it documents the annual expenditure from mining reports, and has to be submitted within 60 days of the anniversary to make sure that things aren't slipping. And it will include the type of projects, the operations conducted, expenditure, and mineral exploration activities. And these things detail the exploration or the prospecting activities that occur, and sometimes they'll have to have a mineral exploration report included as well on top of this. And then again, these reports are submitted through an online portal similar to what you saw before, just to maintain compliance and avoiding delays and forfeitures in the future. Mining rehabilitation fund reports. These is pretty self-explanatory. Essentially, these reports are for all land disturbances that have been caused by mining activities, and then those land disturbances are actually used to calculate the levy contributions that then the mining company has to pay essentially for the land disturbances, and then those have to be categorized appropriately as well for the different types of land disturbances, and all evidence related to the land disturbance also has to be held on for 2 years as well. So the reporting process this reporting process then gets used for other processes too, and that's mainly for closure obligations. So there's a process called the Mining Development and Closure Proposal, and that uses data fed from this report. So it just makes it easier for the government to essentially, keep on top of all these things and have some accountability. And on the right is not from the WA government, but it's from New South Wales, but it's still a good example of how this is the data that's presented back to the public of all disturbed lands and how that's being rehabilitated, and has its own rehabilitation classification next to it as well. And the final one, which is environmental reports, they're the ones that are more commonly known to us. And, if you've gone through environmental science degree or something like that, an example of these is like an EIA, an environmental impact assessment. And these self-explanatory, ensure environmental and community compliance from the community that's going to be impacting. And environmental reports also are used for any incidents that have occurred during the mining activities as well. So it plays a vital role in maintaining its standards and ensuring that mining activities are conducted responsibly and sustainably, and there's nothing essentially dangerous happening on site. The example of some of the spatial data submitted is on the right, where this is an EIA map that's predicting future impact of the region in relation to the mine, where I think this is a limestone region or a quarry of something similar. So actually planning the migration to GDA 2020, and this is probably applicable to mining and everyone as well. One of the initial steps you should be doing is auditing all your spatial data and your systems using it. So you want to go down and identify all data sets that are in GDA94 or other local datums too that'll be converted to GDA 2020, and you should be noting down the data source, the formats, the coordinate systems, and also what their relevance is to your operations. And once you catalog all this, it should help you determine how big the project is that you've got ahead of you. And it also highlights a lot of the data that you're missing too, and maybe some processes you need to put in place to try and recover some of that information. And what it should also do too is show what your critical data sets are and what your legacy data sets are that can't be overlooked or can't be compromised in terms of accuracy. So it might require some more attention when you're doing this transformation. But what you should also be doing is then finding your downstream systems that use spatial data and assess whether they can handle GDA 2020. Do they need to be upgraded? Those type of assessments need to be made. And of course, document everything that you're doing to make this whole process easier and create an audit trail. Reviewing the submission guidelines, this is probably maybe not as big of a point depending on who you are, but it might sort of, doing this process, it might be a good trigger to say if there's a bit of confusion or uncertainty of what you actually have to be doing, reviewing those and understanding the guidelines, understanding the technical specifications and what formats and what type of data or what data, sorry, needs to be included might, just be something that comes off the back of doing this data migration. And if you're able to do this, it starts creating a bit more compliance and efficiency moving forward in your process that have to require submitting spatial data. So another step is just backing up your data and ensuring that you're implementing some version control. So backing up original data sets, it means that if there's ever any errors or inconsistencies that happen during your conversion, you always have the data there sitting there to restore, or it's not lost. And FME is really good for doing things like this, where you can use it to create replica tables and replica data sets that migrate it to there, and also has version control functionality, and also has a really simple way of creating backups for your FME workspaces if you need to maintain the version for that. And then the last one, which is actually probably the most important from a lot of the feedback I've heard, is effectively training your staff and letting them know what's going on and what the GDA 2020 migration is. So this should include, obviously GIS specialists and exploration teams, but data managers and just anyone that is impacted that uses spatial data, because obviously you need to get everyone on board, and you're sort of moving a little bit at your slowest link, because it only takes a couple of people that aren't aware that sort of revert back to old habits, and they're not on board with the new process, and then that's when compliance issues and errors can start arising, or things can be delayed because there's a few things that are in 94 or just processes that haven't been followed to make sure we're all operating on GDA 2020. But that's, I guess, for more the people not involved in the actual technicals of the conversion or the data migration. If for those people, you should really be spending some time trying to explore what transformers work for you and what's the best for your data set. And obviously just working out any of the legacy data or any sort of data sets that might not fit a template and require extra care. So some of the in-house technical solutions, and I guess what I really mean by that is FME and just some straightforward GIS software. So for data and transformation capabilities, FMEs is the one we're going to be talking about as the tool to use. But in terms of just quick, viewer transformation processes, things like ARC and Esri and QGIS work quite well for that. And there's some transformers that can that suit that as well. But if you're using FME, the big apart from you just got a lot more control, is that you can automate a lot of the workflows that you've created as well, which is going to be much more effective for the big bulk batch processing and schedules that's going to be involved with a GDA 2020 conversion. So yeah, I guess what the process will do too, particularly using FMEs, you can set it up for to create auditing and reports along the way. And then this is particularly effective if you need to go back or if there's errors, it's very easy to find what's going on and rectify that. And yeah, just using something like FME as well often gives you a bit more operational efficiency and there's just less downtime. And for example, if you like a lot of the workflows you can configure, if you set those scheduling to be running overnight or configured in way where it's taking advantage of server downtime, that's something that's going to be definitely advantageous to you. And I'll just run through one of those at the moment, and this has just got to do with more project collaboration. So something in FME where this is a feature in FME Flow, where if you have multiple people working on this data migration, this is a space where you can just sort of drop a lot of things, different items. So like these are workspaces that you can drop in, but if you've set up schedules, you've set up automations, anything that's like an object in there or an item can be added and pulled together as part of a project. So these are just some slides that I've gotten back from the first webinar that we did that goes through some of the tools that are used in FME that are really good for converting to GDA 2020. So the two main transformations, I should say, that we'll be talking about and are applicable are the 7-parameter transformation, which is a conformal one, but then also the grid transformation, which is a bit more applicable to us, which is a conformal transformation, but it also handles the distortion of going to a grid that you're naturally going to get when you're converting from a geographic. So this just goes through really quickly a more straightforward conversion in FME, which is just setting the navigator settings and parameters from the source and then the resulting data just to be different data sets. And that's fine, but just knowing it uses the default transformation. So if you're trying to do a grid transformation, this isn't going to be a good way to do it. We need to explore a little bit more. So before I dive into it, I'll just very quickly explain a conformal and a grid. So the conformal is obviously the 7-parameter one we were talking about before, but it applies a 3D similarity transformation, which is quite generic and is good for some things, but if we're for small scale mapping that doesn't need such precise locations, that's quite a good conversion to use and is fitting. Or if you don't have any distortion, so before if you're not going to a grid, you're staying geographic, you don't need the distortion component, so it's effective for that. But grid is applying the distortion correction grid and is better for the large scale hierarchy data, which is exactly what we want for now because we're only dealing with shifts of 2 meters. So if it's small, very small things like that where it's high accuracy, we prefer the grid, which adds the distortion element to the conversion. So the different transformers, there's the reprojector, which kind of does the same sort of navigator simple projection we were talking about. The Esri reprojectors or different ones like that are quite good if the data is going to be ending up in Esri. So the reprojections that it makes are always going to be reprojecting into a native format for the application. So you're guaranteeing it's going to be working if that's where the end result is. However, the bottom one, the CS map reprojector, I think is the best one for this type of one because it handles grid transformations and vertical heights quite well. And we'll show you that in a second. With grid-based reprojections, these are the ones we're going to be handling in this particular project. So I'll go through two of them that handle that. So on the right, you've got the Esri reprojector. You can see in the geographic transformation window, it's including the file that's used for distortion. So that's handy. And then you can see that at the bottom as well with the CSM map reprojector. But the CSM map reprojector's got vertical handling as well. So it gives you more control over exactly what type of ellipsoids or type of profiles you want to use for the for the vertical handling. And attribute reprojection. So if the coordinates are actually stored as attributes, like an X and Y, this is possible as well in FME with the same sort of concepts of whether it's going to be a 7-parameter or a grid based on what you want to use. The attribute reprojector and the projection attribute reprojector, so the separate transformers, they're only conformal and do a 7 parameter. They won't do this distortion. But if you can see in the CS map reprojector version with the attributes, you can actually specify the lat and longs in the X and Y, and also have some control over your vertical handling as well. So that's possible if that's how you want to do your reprojections instead. So just some final comments before I wrap this up. A good thing to mention is some ad hoc conversion tools. So, like a datum converter tool sort of thing. They're obviously not great for doing things in big batches, like you're going to be doing for, database wide stuff. But if you've got people that are sort of remote and they just need to quickly convert this one thing to GDA 2020 before they submit it for something else, or for whatever reason, having something like an ad hoc conversion tool can be really effective. And you can configure it pretty easily through something like an FME Flow web app, or if you want something more custom, obviously something like FME can still be the integrator to that web app. And just touching on site-specific datums, because this is common in mining, and it's obviously something quite different to typical GDA conversions, but essentially these datums, they're more tailored to the site and provide more accuracy where it's more important, particularly with just the sort of operations that they're dealing with. But at the end of the day, these datums still need to be converted to GDA 2020 for submissions. So just using the image on the right, you can see sort of how a custom datum is created from like a scale, rotation, sourcing from an origin point, which is usually a coordinate source. So just knowing the origin, the parameters, the limitations, and all this sort of stuff is going to be really key in performing accurate transformations, essentially. I'll just also now touch on the last thing, which is just ongoing best practices sort of stuff for site datums for future migrations. And really, it's just all documentation, noting it all down, including important metadata. Essentially it makes sense for later on, and just conducting regular reviews and updates to make it sure that it's accurate. And that might also actually include introducing some offsets or maybe some ongoing conversions that make sure that you're keeping up with tectonic shift from where that original coordinate system sits within the custom data set, the data, I should say. And with that is the end. So I appreciate you guys coming through to have a listen. Hopefully it helped you guys a little bit in your GDA conversions. And I'll pass it back now to Daniela, and we'll have a go and look at some of the questions that have come through.